Good afternoon, ladies and gentlemen. We're getting close to the end of the first day, which is going to be great. My name is Eldine. I'm standing here on the small stage. We're going to do a very short presentation. If you'd like to step around and pay attention, I'm going to introduce Michael Mansouri from Radiant Images, and he's going to talk about some exciting projects that we've been putting together with Sony in partnership with Radiant to create some really cool new technology utilizing the Sony RX0 camera and its multi-camera capabilities. So I'm going to introduce Michael Mansouri from Radiant Images, and you can step up and take over from me.
Hi, everyone. Thank you very much. Michael Mansouri, I'm co-founder of Radiant Images. And first of all, I want to thank everyone from Sony for letting us dream big and helping us achieve these. A lot of the things that Radiant works on is the what ifs. What if there were no rules? What if we could do things that were impossible? So we've been looking at virtual reality for many years, and the next phase is what if we could actually physically put our viewers inside of our stories? As the early cavemen dreamt about, how can we put our audiences in these movies? And that was something that was always very fascinating for us, and we were always looking at that as an exploration. How do we do this? So we've been looking at it through different methods. One is volumetric, one is sixth off, and the other one is light field. And with light field was something that we thought this could be actually achieved because the resolution and allows us the ability to move our rigs multiple different locations. So we looked at a lot of cameras in that process, and in our discovery process, we realized that the requirements for these cameras were just really expensive, and the data that you need to use was just unbelievable. Lytro is one example. Their camera counts are all uncompressed cameras. And so we reached out to Sony and we said, what if? And Sony took that plunge with us and said, yeah, what if? What if we did do this? So we reached out to Eldine, and Eldine immediately was very receptive and said, yeah, let's explore. We have a new camera, the RX0s, and it might be a great opportunity for us. So the couple of the requirements that are super important for us for light field is that all cameras have to see the same scene simultaneously. And it cannot be any shutter offset. The shutter offset creates ghosting, and that will take you completely out of the thing. And also, if you wanted to fix that in post, you have to do that frame by frame at 60 frames times 100 cameras. Most companies could not do that. So the reason we looked at the RX0 was, number one, its ability to do frame sync. The next one was its extremely small form factor, where it allows us to position cameras and be portable. So we've been approached by many content creators, and the first thing they talk about with volumetric and light field is, I want to take it to Mount Everest. I want to take it anywhere I want. And the physical requirement of moving rigs was really hard. So when we developed this new system, it's modular. It's designed so that a filmmaker doesn't have to become a scientist and move this into different fields. So it's very portable. So when we got the final go-ahead, it was on March 16, 2018, on a Friday. We sent our drivers down to Sony, picked up the cameras, and immediately realized that we needed a strong partner to help us in the actual solve. Just because you have cameras and you can position it in a rig doesn't mean you're going to have light field. You need a company that works in light field, that has the algorithms and that has the expertise. Of course, the first call after that was, I called up Ryan, and Ryan immediately, he's like us. He says yes, and then he figures out how to do it later, right? How many times have we done that, where we say yes and we're like, oh my God, what the hell? So Ryan said, sure, I'll be right there, and he showed up in our place on Saturday morning, and that's our next slide. Oops. So, back up a little bit. So Sony, when we discussed this project, we wanted to come up with two solutions for them. One was light field, another one was bullet time, but in a different capacity. Not these big, huge rigs that are impossible to move around, position underwater, position on top of a hood of a car, things that one person could actually do by themselves and get these, not just bullet time, but a virtual dolly move. for us to actually physically move these cameras from one perspective to another perspective. So the other idea was for us to build a bullet time system. So this bullet time system is the same one we partnered with our partners from Stargate to capture underwater virtual camera dolly moves. So this is based on 70 cameras. And this is our light field camera capture system that Ryan helped us to build. And we'll show you the build process because it's actually pretty interesting. So as you can see here, these are windows. This is 4 feet high, 3 feet wide. It's designed to be portable. You can place it in a shipping container and ship it. All the cameras are all equiplane, and we're able to readjust how close proximities are. So if someone's super close to us, that can be adjusted for that. This is our first light field system. So soon as we got the cameras, we just physically had no time. So Ryan and I got into a car. We went to the first Home Depot, bought out every single aluminum rod system, steel rod system they had, nuts, washers, and then we went to a second Home Depot to clean them out as well. So we went to many places, and this was our first design that we used to prove the test. A lot of things in light field are really theories, right? It's the what ifs. No one's actually done this like in this method, including what we did, because by the mathematics, it should be impossible. We have cameras that, are not uncompressed raw cameras, right? They're not completely 100% a gen lock camera, but they are actually frame sync cameras. And with these, we're able to actually take these cameras and position in complete light field system. So it was actually more than a proof of, we actually were able to prove this, but our first test was here. Then this is our first prototype for our bullet time system. Now we've refined it. We designed it in a way that it could be adjusted and pan and tilted. And this is the process for us to build out our first system. So we came up with a power management system, and we came up with utilizing their sync to be able to trigger all the cameras simultaneously. The problem is if you do not have a perfect sync and bullet time, to line up all the cameras, it's going to be very difficult. And we were not interested in doing single frame because we don't know what we're going to be getting, especially underwater. We position a camera and we hope the performers perform for us and we find interesting things to pull out of this. So we're talking to people like Shark Week. They want to use it for underwater to capture like a shark coming right up to the camera. And if this was based on a single frame, we might or we might not get the shot. Most of the times you don't get the shot because we might be out of frame. So this is our light field system again, and that's our power management. As you can see, this is our one by one. We had to build these systems together. And this is our first virtual dolly move in a car. So we start off with a hero shot on a driver, and we move to the passenger. And we couldn't do this normally with normal bullet time system. I'm driving, the actor's driving the car, they're having full dialogue, and the cameras are super small, and we don't have to worry about framing because we just tilt up, and we don't have to worry about any of the, seeing the other cameras. And then that same day, we just flipped the cameras onto another one with suction cups. So we're not using like big speed rails, and we don't need 20 grips to put this together for us. So we also utilized their camera in another approach by using a very high-speed spin head. So here we have an extremely fast spin head, and that gave us a virtual bullet time as well. The one thing that we noticed on their cameras is there's no rolling shutter artifacts, and that's really important. We're spinning these cameras as fast as possible, and we don't get any wobbly images. And that's also extremely critical for light field, because if we're scanning an image, imagine the precision that's needed. All these cameras have to see the same exact subframes accurately from every different position. If one is off, if there's motion blur, we'll sense that and you can see it in the frame. So with this one, we're able to start off with a very low angle shot, spin her above her head, and reveal her. And that's us putting this stuff together. And this is us taking all these cameras, putting it underwater. And I think we have some BTS we can share. Yeah. Oh, yeah. Where's Sam? Is Sam? No. Okay. So guys, what we're doing here, we had the new Sony Venice that Sony provided us. We shot with anamorphic as well as spherical. We had our underwater housing, and we started shooting some of the elements for our first time bullet camera array underwater. And here we have 70 cameras, and there's Sam. He's speaking very highly of me here. And here's all the cameras. And the great thing is that we were able to get all the cameras synced. Their cameras are already waterproof up to 33 feet. We didn't have to put any housing. Imagine if we had to put housings here, watch for batteries. So all the battery management is getting charged externally. We just remove the cable. We plug a small plug, and it goes underwater. We had some friends from Fox Fury that provide us underwater lighting. And what we did is we created a studio underwater. So we just blacked out the entire pool with black, and we just brought one big source light to create this really godlike, light source. And there's Sam taking that camera underwater. And this is Igor. He's one of our cinematographers on this shoot as well. For once, I don't know what to say. This is amazing. Speechless. Okay, so this is the Venice, and then we're going to cut to the Sony 6300, and then we're also going to do some stuff with the RXO as well. So they intercut very well between each other. So we checked here. There was no leakage, which is good. Everyone's happy. And I got to say something about the Sony interface. So they have a web app that is so simple for us to, if this was someone dropping off cameras to us 3 weeks before NAB, traditional method, we wouldn't be ready. We'd still be syncing it. So the critical factor is they just gave us tools. They also gave us tools that were ready to implement in this capacity. So we're synced all these cameras with one single laptop, and they're perfectly synced across the board. This was shot last Sunday. It took us a few days to download the footage, make sure it's organized. We handed off the drives to Stargate on Wednesday. They stitched all this on Friday and handed us to today. So this is the interface on that laptop. So this is the bullet time from the camera. This is the RXO. Okay, yeah, definitely a tearjerker. Control L, okay? All right. Control. Oh, the L is so far away. Okay. So, to create this kind of technology, this kind of new methods of thinking, it's definitely a collaborative participation. We couldn't have done this without Ryan and his team. And let me introduce Visby and Ryan. We're going to share this deck because we're going to actually take something that we've learned. And I got to say one thing about light field. Even the most knowledgeable person, which is Ryan, he's been
my team.
your team. But anyways, extremely, as well as the people who know nothing about light field, it's pretty much about even right now. We're still learning. This is a new method of learning about how we can take our audiences inside of a scene. This is like the first time man discovered electricity. What we're doing with it now, it's amazing. What we could do with this technology next 2 years, 5 years, or 10 years could be incredible. That means that we've completely lost this screen. We can actually now move within that screen and break the fourth wall. So I'm going to have Ryan, describe how we got to this technology and what are the current limitations. There are things currently we just don't know how to do. It's not the technology, it's just mostly us, right? We're trying to still figure it all out. Every one of us, not Ryan, just the entire industry. We're trying to figure out how to create the most we can. So, Ryan?
Yeah, thanks. I think Michael mentioned earlier that there's a lot of different approaches to capturing immersive images, and light field's just one in this larger array of techniques. What distinguishes light fields from other approaches, at least at first glance, is the sheer number of cameras you need, right? Oh, so we got images to back this up. So 360 video, typically you got enough cameras to cover your entire viewpoint, and you got to stitch the images together and away you go, right? So low end arrays, 5 or 6 cameras, high end as many as 20, and that seems like a lot, but that's not even scratching the surface if you want to go capture a light field. The array we have over here is kind of your table stakes for a light field. Yeah.
So part of what happened with Radiant, we're constantly asked, what's next? How do we add more immersive experiences for our viewers? So we've been looking at volumetric and LiDAR and light field for about 2 or 3 years now. And seriously been partnering with Visby on creating the solves. And part of what we did is looked at the discovery of how the technology cycles work and why it makes sense for us to even think about light field and volumetric. If we look at the technology cycles, so let's just start from mainframe computers in the 60s, then we had computers in the 70s, personal computers in the 80s, and then in 2000 we had smartphones, and then we had wearable. The next technology cycle, if you listen to all the experts, it's wearable computing. It's watching things and viewing things in non-traditional 2D. It's with volume. So you can actually physically have a volume of the object that you're working with in physical space through glasses or with your mobile devices. So that's why we're looking at this in a much more serious manner, because the display technology is already there. If you look at the announcements with Microsoft, with the HoloLenses, and all the headset manufacturers that have cameras in their headsets, that's what it's for. It's the MR, AR viewing devices. So we need to create content that supports those viewing devices. And those are coming from the largest tech companies in the world. It's the Googles, it's the Facebooks, it's the Sonys. They're creating holographic experiences. Now we need to create content that best fits this. So part of what our discovery was, we looked at volumetric and we looked at also light field. The main deciding factor for us was resolution and the freedom of movement and being able to capture not just the subject but also the background. Light field has that potential already, and we're developing more and more capabilities in that, right? So I'm going to pass it back to Ryan.
Yeah, and I should say big thanks to Sony for really giving us this opportunity. The truth is, we've been working in light fields for a couple of years, and getting access to the RX0 was a really big upgrade for us. The quality of a light field is a direct function of the quality of the pixels you put into it, and what came off those RX0s was just gorgeous. The cameras were rock solid sync, the color was beautiful, we were able to grade a really incredible image off of it, and the workflow was really clean. So for a 3-week sprint would not have at all been possible if we had to fight the cameras. So we were really fortunate in that regard. And so at a high level, a light field, what distinguishes it from these other approaches is going to be the fact you just have so darn many cameras, right? The idea is as the user's moving around, you have to draw on light rays from multiple cameras to deliver the image. The alternative is to have a volumetric solution. We've got the shape of the world, and a game engine simulates it along the way. And what you'll see if you try out the VR headset demo, if you look at the video demo that we've got, the images that come off of the light field are equivalent to what comes off of a single camera. And that's really powerful. So yeah, here's the array as you can see. Actually, this is your bag, Michael.
No,
all right. Yeah, I mean, so I think what really motivates the light field approach here is that we want the experience of shooting a light field for these immersive platforms to be similar to shooting traditional video for a traditional shoot. It shouldn't look like a pure VFX shot. It shouldn't look like I'm making a video game. It should look like I'm setting up cameras and I'm filming a scene that just happens to be immersive. We're not there yet. There's still a lot of hand-wringing and VFX work on the back end, which we're trying to make easier, but it's getting closer and closer to actually setting up like a traditional shoot. And that's critical, because I think the future of capture still has to be cameras. So, this is a spec sheet, which should scare everybody. One thought on this, by the way, we were riffing on this morning, but you know, when we think about upgrading an image in 2D, you always think about getting a better camera and better optics to get a better image out of it. I think the future is actually going to be, for these immersive platforms, is you just add more cameras. Because every additional camera you have gives you more information about the scene. It turns out, counterintuitively, you can actually improve the color depth and you can improve resolution with more and more cameras. So the future looks a little different in these strange ways. It's a strange change is coming from the displays that's going to work its way back into the capture. One other thing that really affects the quality of a light field is how tightly together you can pack the cameras. We found, I think, a very nice compromise between keeping the cameras close enough to generate a nice light field and not having to have a totally preposterous amount of data to work with. The images that come out of that array are extremely clean, very sharp, and you're actually not wrangling petabytes worth of data. It's big, but it's not crazy. You're all over the place, Michael. Come on.
So lens field of view.
You want to talk about field of view? Oh yeah, so another interesting thing about these cameras versus the sort of traditional VR camera you assemble into a ball is they're not fisheye lenses, right? They're a modestly narrow field of view, I think 74 degrees by 46, not 180, not 150. On the one hand, that means that you need to have more cameras to cover the whole scene. On the other hand, it means you have many more pixels per degree, and that's, in an immersive environment, that's what determines how sharp your image is going to be at the other side. Because the headset determines the degrees, pixels per degree for the user, so you got to meet them with as many pixels as you can. And the RX Zero actually lets you do that. You can get a very, very sharp image out of it because I think it's 5 or 10 times the pixels per degree.
We were actually shocked about just the image quality. I mean, it's a 1080 camera, but the pixel per degree, it's at least 5 times sharper than any fisheyes. It's just because we're getting a lot more density of resolution, small area. And then I think we should maybe talk to them a little bit about resolution, because everyone, it's a weird thing about resolution and light field, because it's not really about the K's of resolution, it's more about vantage views. So maybe you can expand that.
Yeah, I mean, so in a light field, you're actually drawing on pixels and light rays from multiple cameras at one time. So the actual resolution of the individual camera is not nearly as important as how you set up your cameras and how you describe the space. And there are technically, we have some renders that we're getting 4K images out of a 1080p camera array. So it depends on the field of view, depends on the location of your virtual camera. But at the end of the day, this is all driven by this bizarre world we're in, where in these immersive devices, the pixels that the user is seeing are not the same as the pixels you shot, right? They're being remapped and squished and torqued. And that's a big disadvantage in a lot of cases. But the one advantage is you can actually get higher resolution than you think out of these small cameras when you pack a lot of them together.
We also discovered that our bit depth increased. You know, we started with 8-bit. Now we're at least 10-bit, 10 log, yeah, which is great. So that's another advantage, because we have so much oversampling. When you have so much oversampling of seeing this, it's like having a tracing paper, and you can see it from so many different vantage points. You're just adding a lot more color information. So synchronization?
Sync is huge. We have fought rolling shutter artifacts in inexpensive cameras for a very, very long time. I was blown away when we started comparing frame to frame the RX Zero arrays. I know they call it a rolling shutter, but it might as well be global. We had imagery, which you'll see on the video screen at some point in the VR headset, with flame. There was a fire dancer. And that flame, she was raking these fire fans across the field of view. And we went from camera to camera that all had the flames in a different position, right? So you'd expect different exposure times, right? Yes, they're shutter synced, but the rolling shutter artifact should show a little variation. Nothing. I mean, the exact little sparks coming off of the flames were in the same spot. So I don't really know what they're doing under the hood, but it was absurdly well synced. Really, really fantastic. No rolling shutter artifacts at all. And that makes a big difference. In a light field, if an image is actually in a slightly, if an object is in a slightly different spot from camera to camera, the software has no idea where it actually is in real space. The net effect oftentimes looks a little bit like a motion blur, but maybe a little worse. So having that really, really hard sync was, really, it just affects the final quality. It's a really powerful thing.
I think we're mostly impressed by the rolling shutter artifacts. Because, yeah, I mean, imagine shooting a flame moving through a scene. Most cameras would definitely have an issue. So resolution, what we talked about.
Yeah, we talked a little bit about bit depth and resolution. Sometimes you can think of these arrays not as a bunch of 1080p cameras, but as a 100 megapixel capture device, right? You really do have the advantage of all those additional pixels. The color depth was a little counterintuitive though, but the idea is when you're drawing on more than one camera's worth of color data, you get a little bit of noise in there, and you can actually, when you grade it, it doesn't band nearly as much. So we estimate, we didn't do any measurements yet, but shooting an S-Log on these cameras, it's in 8-bit, but then when you go grade it in a light field, it's the equivalent of at least a 10-bit log image. And you can do a lot with a 10-bit log, so that was really nice. Having been shot in linear light 8-bit before this, the upgrade was massive.
Frame rates.
Frame rate, this thing does overcrank, it's beautiful. We shot most of our tests at 60, but we did do 240 and 480. And it's really clean. It's really amazing how the overcrank works. Yeah.
So video compression. So this is counterintuitive because in the past, like let's say if you asked us about a couple months ago about compression, we would say no, it has to be uncompressed. As we could see, uncompressed is just not possible with 140 cameras all shooting at the same time. Your file size would be, each frame would be like 11 terabytes or 13 terabytes per frame. There's no post house that can service that. It would only be like a Google or Amazon. There's no one that can really service that. So the compression actually helps us. And we didn't see any noise compression or any artifacts in compression, which is typical what you see on small sensor cameras. But in compression doesn't hurt you.
No, the reason compression doesn't matter as much, first of all, if it's uncompressed, you're done. You have such a big data problem, you're never going to get it solved. But when you go from camera to camera, any compression artifacts are not correlated with one another, so they tend to be, the algorithms tend to reject them. That said, when you look at the raw images coming off these cameras, there are not compression artifacts to speak of. It does a really good job in camera. Power. Power is like the other big thing that just ruins a large array shoot. Because you think of these little cameras, relatively small form factor, relatively small sensor. Okay, they draw 500 milliamps, who cares? Well, you multiply 500 milliamps times 50 or 100, and you're melting cables. We've smoked out more than one camera and more than one power supply. But we found that power management with these was really, really clean. In fact, they all take 5-volt USB. You can wire them up. Radiant has done a good job of actually making them powered off of traditional cinema batteries in large scale, and it was actually really clean. So, you're not swapping 50 batteries, you're not charging 50 cameras ahead of time, you're not pulling 50 micro SD cards, you're treating it like one camera. You can worry about 2 or 3 batteries at most, and you worry about pulling the data off of the array camera all at once. It's really, really clean. Data offload, sorry. That's the other big problem, and it's well solved. There's a beautiful, you can play with the web interface over here. It's really clean. It's DIT ready. I tell you, it beats the heck out of fumbling around with most micro SD cards.
So, imagine if you had to go to every individual camera, pull out SD cards from each camera, keep them organized, make sure that their file naming structures are identical. So what Sony's developed is we can go to each individual camera. I could put unique camera roll numbers, and what we've done is we put a barcode number on there. So we know that this camera is camera 001, and if camera 001, something happens or it gets smacked or something, we replace it, and that new position will be 001. So we have a filing name structure that Sony's provided us. So if I just hand a DIT a whole bunch of cards, they would be very easy for them to bring it in. It's all organized through the file management system. But the great thing is that we actually don't have to take cards out of the camera. We hit a button and the cards download. We don't touch the cards, and we don't touch the battery. So we're constantly sending power to the cameras. So all those things I think Sony thought about is how to create a multi-camera capture system leave it in an environment, and not touch it. Yeah, so basically, reliability, calibration, color. So their software does not require any calibration other than a physical chart. Physical calibration, yes. Yeah, no electronic calibration. So that's really important for us. But that's part of the process that we're building with Visby is a new method so that the calibration is just a couple bangs and you guys go out, you're able to shoot your content. It gets uploaded to their cloud, and their cloud does the solve, right?
There's a few steps in between.
Yeah, we're just trying to sum it down. So anyways, I think we're end of our presentation. If you have any questions, we'll be more than happy to answer it. If you guys want to see any demos, we have some demos of the content in the 6-staff. So currently what we're showing right now is one single frame because of the turnaround time they have to deal with, but we can easily do videos. Videos is not a problem. We can do motion picture videos, and you could have your audience with a headset walk right up to the subject, or in post, you can virtually move cameras at any perspective. So we see this as a much more tool than just immersive, but how the content creators actually are able to move cameras, reposition them, reshift, refocus, and again, we're like the early stage of discovering electricity. There's so many other things that we can do with this technology. It just requires imagination and people who are bare enough to be out there trying out new stuff. So, yeah.
I just want to riff on that for a second. We've been struggling and building this technology for 2 years now. We're finally at the point where it's time to plug creators into it so you guys can break it a little bit, find out what works, what doesn't, and really push the technology to the limits. It's working, but it's time to really do something cool with it. So.
Thank you. Thank you very much.